Is cooling a process of creating a vacuum? No, cooling is not a process of creating a vacuum. Cooling is primarily concerned with the process of removing heat or reducing energy. Vacuum can reduce heat transfer, but it is not a direct way to control temperature. Common methods of cooling include refrigerators, freezers, liquid refrigerants, and heat exchangers. Vacuum can help control heat in high-temperature environments by inhibiting heat transfer, but vacuum itself is not a process of cooling. Does slowing down the movement of atoms lower the temperature? Yes, slowing down the movement of atoms is a common way to lower temperature. Temperature is related to the average kinetic energy of atoms and molecules in a substance, and lowering this kinetic energy will lower the temperature. Generally, to slow down the kinetic energy of atoms and molecules, you need to remove heat or add less energy. This is done using devices such as refrigerators and freezers, which can slow down the movement of atoms and molecules to lower the temperature. Here is a more detailed explanation. 1. Temperature is a measure of the average kinetic energy of atoms and molecules in a substance. 1. The higher the temperature, the faster the atoms and molecules are moving. 2. To lower temperature, we need to slow down the movement of atoms and molecules. 2. We can do this by removing heat or adding less energy. 3. Removing heat can be done by using a refrigerator or freezer. 3. These devices work by using a compressor to remove heat from the inside of the refrigerator or freezer and transfer it to the outside. 4. Adding less energy can be done by using a heat sink. 4. A heat sink is a device that absorbs heat from a source. In conclusion, cooling is not a process of creating a vacuum. It is a process of removing heat or reducing energy to slow down the movement of atoms and molecules. What is the temperature of a perfect vacuum? The temperature of a perfect vacuum is undefined. Temperature is a physical quantity that represents the average kinetic energy of atoms and molecules in a substance, and the concept of temperature does not apply to vacuums because there is no matter in a vacuum. Therefore, it is impossible to define or measure temperature in a vacuum. In a vacuum, other physical variables such as pressure and volume are used to describe the state instead of temperature. Does lowering the pressure to lower the temperature work? Lowering the pressure to lower the temperature does not generally work. Temperature and pressure are interrelated by the ideal gas law, one of the physical variables that describe the state of gases or liquids. According to this state law, the temperature tends to decrease when the pressure is lowered. However, this is a rule of thumb in general situations and does not apply to all situations. To lower the temperature, it is generally effective to slow down the kinetic energy of atoms and molecules by removing heat or adding less energy. Lowering the pressure can help to lower the temperature, but it is not the main method in itself. Here is a more detailed explanation. 1. Temperature is a measure of the average kinetic energy of atoms and molecules in a substance. 1. The higher the temperature, the faster the atoms and molecules are moving. 2. In a perfect vacuum, there are no atoms or molecules. 2. Therefore, there is no average kinetic energy, and temperature is undefined. 3. Lowering the pressure can help to lower the temperature in a gas. 3. This is because the lower the pressure, the lower the average kinetic energy of the gas molecules. 4. However, lowering the pressure does not always work to lower the temperature. 4. This is because the temperature of a substance can also be affected by other factors, such as the heat content of the substance. In conclusion, the temperature of a perfect vacuum is undefined. Lowering the pressure can help to lower the temperature in a gas, but it is not the main method in itself.